Hi, this is Chris. I'm here to talk about isosceles triangles. This is from Mathematics for Machine Technology by Smith and Peterson. I'm an instructor at Shoreline Community College. We're looking for the distance between two holes. Often this is done by using the isosceles triangle principle. Here we have a bolt circle with 6 holes equally spaced around it. We calculate the distance between the two circles by constructing an isosceles triangle from the center of the bolt circle. Let's say we pick these two holes that we label A and B at the bottom of the bolt circle. We want to find the distance shown in blue from A to B. Now we draw lines from the center of the bolt circle to the center of each circle. Each of those lines is a radius of the bolt circle. Next, if we draw a perpendicular line from the center of the bolt circle to the center line between A and B, the line splits the angle at the center in two and splits the length in two, the length of A to B. So what information do we have about this triangle? We can determine the central angle because the number of bolt holes evenly spaced around the bolt circle. We divide 360 degrees, the total number of degrees in a circle, by the number of holes in our bolt circle, 6. That gives us 60 degrees. Then our vertical line splits that in two, so we divide that in two, and that means our central angle is 30 degrees. We also know the distance from the center of the bolt circle to the center of either small circle. That's the radius of our triangle, half of 2.2. So if we divide that, we find that the radius is 1.1. That's the distance between the center of the circle and either point B, the center of circle B, or circle A. So what side of the triangle do we have? We have the radius, which is the hypotenuse of the triangle. What side of the triangle are we looking for? We're looking for the opposite side. So which function will we use? We need a function that uses the opposite and the hypotenuse. That would be the sine function. So the sine is equal to the opposite over the hypotenuse. Using our bubble diagram, we're looking for the opposite, so we cover it. That tells us we multiply the sine times the hypotenuse to find out what the opposite is. Plugging in the numbers, the sine of 30 degrees is 0.5. The hypotenuse is 1.1. We multiply and we get 0.550. That's the opposite. But the opposite is only half the distance from A to B, so we have to multiply that by 2. When we do that, we find that the distance from A to B is 1.1, 1 in 100,000ths inches. Now, was there an easier way to do the problem? Yes, there was, if we realized that the triangle is an equilateral triangle. Each of the corner base angles is 60 degrees. That means the upper angle, twice 30, is also 60 degrees. That means that the triangle is equilateral and the distance from A to B is equal to the radius from the center of the triangle to B or A. So the distance from A to B had to be 1.1, which was exactly what we calculated. I hope you enjoyed this lesson. Bye.